Hi everyone. So in this video we are going to discuss the reaction of alcohols with hydrogen halides. Okay, this is one more type of reaction which involves the cleavage of carbon and oxygen bond. So in this reaction, the alcohols react with the hydrogen halides and a substitution reaction takes place, and we get alkyl halide as a product in this reaction. Okay, with water as a byproduct. So the reaction is between an alcohol and a hydrogen halide. Okay, the hydrogen halide X here represents a halogen, which can be chlorine, bromine, or iodine, any of these three. Since fluorine is less reactive, so hydrogen fluorides are not as that much reactive in normal conditions with the alcohols. Okay, so when alcohols react with the hydrogen halides, a substitution takes place, producing an alkyl halide and water. That is depicted by this general reaction here. Okay, so the order of reactivity of hydrogen halides is this. So hydrogen iodide is most reactive of all hydrogen halides towards the reaction with alcohol, and the hydrogen chloride or hydrochloric acid, which we call as by general name. So this is least reactive of this is least reactive of all the hydrogen halides. Okay, and if we talk about the reactivity order of alcohols, then primary alcohol is least reactive, and the tertiary alcohol is most reactive with the alcohol. One of the prominent reactions of this category is the Lucas test. Okay, in Lucas test, we have an alcohol which is reacted with hydrochloric acid in presence of zinc chloride, chloride as catalyst, and we get the corresponding alkyl halide in this case. Okay, so if we are using zinc chloride and HCl as the reagents and react them with the alcohol, so we call such a reaction as Lucas test. Okay, these reagents are called as when HCl is taken in presence of zinc chloride as catalyst, means zinc chloride is used as catalyst, then these reagents are called as Lucas reagents. These are called as Lucas reagents. And Lucas test is actually a test to distinguish between the three types of alcohols. With the help of this test we can distinguish between primary, secondary, tertiary alcohols because they all the three alcohols, different types of alcohols, they behave differently towards the Lucas test. So if we take an unknown alcohol in a beaker, and to this we add HCl in presence of zinc chloride, this is catalyst. So if there is a turbidity, precipitate is formed immediately. A white precipitate is formed immediately in the reaction. Then the alcohol that's present in the beaker will be tertiary alcohol. Because why? Because tertiary, as we already told, they are the most reactive towards the reaction to the hydrogen halides, and they are most reactive. Okay, they are converted into the corresponding alkyl halide immediately when they are reacted with the HCl and the zinc chloride. And if we take an unknown alcohol and add same reagents to that alcohol, and the product, the precipitate is formed in 5 to 10 minutes. 5 to 10 minutes it takes to form a type of turbidity, a type of precipitate in the reaction. Then this alcohol will be 2-degree alcohol. This is secondary alcohol. Okay. And if we take an unknown alcohol and add the same reagents to this alcohol, and no reaction takes place at room temperature. Okay, no reaction takes place at room temperature, then this alcohol will be a primary alcohol, because primary alcohols are not reactive to the Lucas reagents in normal conditions at room temperature. Yes, if we increase the temperature, then we are forcibly reacting these two species. Okay, so this is the basis of, this is what actually Lucas test is. The reactivity of different alkyl halides towards the Lucas reagents determines the type of alcohol. This test is used for the identification of the three types of alcohols. Okay, this is what Lucas test is, and in Lucas test we use reagents. HCl is used in presence of zinc chloride. Okay, this zinc chloride is just a catalyst. This is not used in the reaction. Now we will discuss the mechanism of this reaction. So the mechanism is simple substitution reaction. Okay, the secondary, tertiary, allylic and benzylic alcohols, all these types of alcohols, they follow the SN1 mechanism. Okay, SN1 substitution reaction, because this reaction, there is a formation in this reaction, there is a formation of a carbocation as an intermediate. So this follows what SN1 mechanism. And the primary and methanol, primary alcohols and methanol, they follow the SN2 mechanism that will also be discussed in next slides. So what happens when alcohol is reacted in presence of a zinc anhydrous zinc chloride? Okay, anhydrous meaning there is no presence of water in the reaction system, that is zinc is without water. So there is the attack of this lone pair of electrons that's present on the hydroxyl oxygen, and there is a formation of a complex with this zinc chloride. Okay, there's a negative charge on the zinc chloride and positive charge on oxygen. So oxygen having this formal positive charge is now unstable. So to become stable, because it's also more electronegative than carbon present on this R group, so it takes the pair of electrons towards itself and leaves as a complex like this. Okay, and having a negative charge, and we're getting a R positive, which here represents, this is a carbocation as an intermediate. So this is the intermediate in the reaction, and in next step we add the hydrogen halide, and this hydrogen goes to the this complex. Okay, and this leaves as zinc chloride and water. Again there will be ZnCl2. These two will be the byproducts of the reaction, and this X goes to the carbocation. As a result, this alkyl halide is formed. This is alkyl halide. So this is the general reaction mechanism here. And if we take a particular example, we have this. Again, we have taken this is a 2-degree alcohol. This is a secondary alcohol as an example we have taken here. So it follows the same reaction mechanism. The lone pair of electrons on oxygen that attacks this zinc chloride, and an unstable complex is formed here, in which we have carbon having a formal positive charge. Okay, to stabilize this forms a carbocation. So a 2-degree carbocation is formed in this reaction, and we get this complex, this negatively charged complex here, negative charge on the hydroxyl group. And in next step what we are adding HCl in the reaction, and this Cl goes to the carbocation, and we get ZnCl2 and water as the byproduct in the reaction. Okay, so we get this type of alkyl halide in this particular example. Okay. And now if we talk about the reaction mechanism of primary alcohols and methanol, it will follow the SN2 mechanism. Okay, this is following again this is substitution reaction, but is SN2 mechanism. This is a concerted mechanism. It goes in just one step. The making and breaking of bonds as shown here is just simultaneous. There is no formation of any intermediate, no carbocation formed in this reaction. So this is the reaction. Actually what happens, we have an alcohol. This is the molecule of alcohol. When it is added to the hydrogen halide. Okay, general example we are taking here. So hydrogen halide, the lone pair of electrons on oxygen is just acid base reaction. It takes the proton, and the X negative will be okay, the hydrogen ion will be left with this negative charge, and we have a complex. We have a oxonium ion. Again, this is oxonium ion and positive charge on this oxygen. In next step what's going to happen, this is not a carbocation. Okay, we don't have positive charge on carbon. The positive charge is on the what you call as the oxygen. In next step what happens, the X negative that has been expelled in this reaction, that attacks the carbon, Okay, so this bond breaks and oxygen takes the lone pair, and we get Rx plus water. Okay, so this is a simple reaction mechanism. It's just concerted. This bracketed structure here, this is the transition state in the reaction. This is the transition state, not the intermediate. This is transition state, it's very short-lived state, which represents that this bond is formed and this bond is broken simultaneously. As a result, we are getting the alkyl halide and the water in the reaction. Okay, that's all about this particular reaction. In the upcoming video, we'll be discussing the other reactions of alcohol.